So this question is asking us to graph this quadratic function and find the domain and range. So what I am imploring you to do is to pause the video and try that on your own and compare it with my answer. And after you find it, you can push play and check it against yours and make sure you got it correct. So, first, we want to find the axis of symmetry. In order to find the axis of symmetry, we're going to get x is equal to negative b over 2a is equal to, that's our b. Your b is the coefficient of the linear term, negative 18 over 2, 1, is equal to negative 9. Okay, so our axis of symmetry, or where this parabola is going to fold, is at negative 9. And this is going to be kind of hard to graph in this table of values, but I'm going to, on this coordinate plane, but I'm going to wind up extending it. So now we have to find the vertex. So all we have to do is find the y of the point. And we're going to have a minimum with this because our leading coefficient's a positive, and our parabola is going to look something like this. So we're going to have a minimum, which is down here at the vertex. Let me erase this. Keep going here. So I'm going to put the negative 9 into the original equation, squared plus 18, negative 9, plus 41. So we've got positive 81, minus 90 plus 72, which is 162, plus 41. And we wind up with y is equal to negative 40. And that means our vertex is happening, well, that means two things. That our vertex is happening at negative 9, negative 40. And something else that means is we're not going to be able to graph it on this coordinate plane. So what I'm going to do is get rid of that. And I made my own, which is quite ugly, I must say. But at least we can kind of get an idea of what this parabola looks like. We're at negative 9, negative 40. We're down here. And if you get a question that says, what's the minimum? Well, negative 40 is the minimum, because that's as low as your parabola is going to go. Anyway, we weren't asked that, though. We have to find the domain and the range, and we'll figure that out later. So, let's go ahead and continue drawing our parabola, and we are going to find the X-Intercepts. In order to find the X-Intercepts, you can do it one of three ways. The first way, the most preferred and easiest, because it's the easiest way, is factoring. But we look at this equation, we see 41 is prime, so this really isn't factorable. So we're going to have to either complete the square, or we're going to use a quadratic equation. Personally, I prefer to complete the square, so with this problem, that's what we'll do. And we could practice the quadratic equation on another problem. So what is our value of y when we're on the x-axis? 0. Okay, it's right here on the axis. So our value of y is 0. So we're going to put 0 in for y. We're going to subtract, to complete the square, you want to get the constant on the opposite side, plus 18x plus 41. And we're going to do that by subtracting 41. Okay, so I'm going to leave some room here. 41 is equal to x squared plus 18x. Now, what we do to complete the square is we take the coefficient of the linear term, and we're going to create a perfect square. So we're going to divide it by 2, and then we're going to square it. So we really have 81. And we're going to add that 81 to both sides. And there's a video in Google Classroom about this as well. So if you want to watch the video, if you're a little rusty at this, if you will, you can watch the video. Okay, we just completed the square. So we're not done yet, though. We have to get rid of that square. So we're going to take the square root of both sides, and we wind up with x plus 9 is equal to plus or minus square root of 40. Okay, so we can actually simplify this radical. I'm not going to go into that right now, though. What I do want to say that if you leave it like this, oh, actually we're not done yet. We've got to get the 9 over both sides. So we've got negative 9 plus or minus the square root of 40 is equal to x. And I'm going to go ahead and change it to a decimal because, and I know I said you can leave it in this form. I said you can simplify, actually I told you I'd prefer you simplify the radical, but if you don't, I'm not going to mark it wrong on this week's test. But to graph it, obviously, to find the x-intercepts, we have to change it to a decimal because we really don't know what the value of the square root of 40 is. So the square root of 40 is 6.3, rounded to the tenths. Negative 9 plus or minus 6.3. So that means our x-intercepts are happening at two places. They're happening at negative 2.7 and negative 15.3. So we're going to come up to the graph, and I'm going to have to approximate because my coordinate plane is so imperfect. So 2.7 and negative 15.3. And we're going to get a parabola that looks something like this. Now, if you just have a regular parabola, by regular I mean not an inverted parabola, which we're not going to go into in Algebra 1. You'll be seeing it in Algebra 2, I believe. Anyway, your domain is always going to be all real numbers. It's nice because you can always remember, yeah, my domain, because this is going to keep spreading out. So the domain is all real numbers, and our range is, like I said before, the minimum is at negative, what was the minimum? Negative 40. Did I write the vertex? Yeah, I think I erased it, but anyway, our domain is y is greater than or equal to negative 40.